So yesterday we looked at adding and subtracting to solve equations, and today I want to finish that off by showing you how to solve equations by multiplying and dividing. And so just to review, remember our goal is to get the variable or the letter by itself on one side of the equal sign. And in these types of problems today, it will be more likely that you might see some fractions. And so if you come across a mixed number, remember that you need to change the mixed number into an improper fraction. Okay. So no mixed numbers, they need to become improper fractions. And again, just like yesterday, we have to use opposite operations to cancel things out. So if we're trying to get rid of something that's being multiplied, remember multiplied could just be two things that are next to each other like this. 2x, that could be a multiply. A multiply could look like that. So if you have things that are being multiplied, remember to get rid of them. You're going to divide. Or sometimes what you might need to do is you might need to use reciprocals. So if you end up with a fraction that's next to the letter looking like that, to get rid of that 1/2, you're going to have to use a reciprocal to get rid of it. Okay. And as always, whatever you do, make sure that you compensate on both sides of the equal sign. So let's look at some examples here, starting with number 1. And so for number 1, 8x equals negative 736. So that's a big number. You can write on your piece of paper, get your calculator ready. But right now, let's look at the 8x. Remember, x wants to stay at home by himself, so we got to get rid of everything around him. So we have an 8 next to him, and this is different from yesterday because remember there's no plus or minus in between the 8 and the x, so if they're just next to each other like that, it's multiply. So if the 8 is being multiplied to the x, remember the opposite of multiplying is dividing, so that means I'm going to divide 8 on both sides. And what happens here? This cancels out and this cancels out, and it looks like that. And believe it or not, negative 736 divided by 8 actually goes in evenly 92 times. And there's a negative, so I just dropped it down. Okay. Looking at number 2, here's a situation where we have one where it's a fraction being multiplied. So if you end up with a fraction being multiplied, let's write that here in the purple. So you use it when there's a fraction being multiplied. And that looks like that. Okay, so there's a fraction being multiplied, so we have to use a reciprocal. So the reciprocal of 1/5 is 5/1. And if I do that there, I'm going to have to do that on this side. Remember, 5/1 is the same thing as 5 too, so if you don't want to put that over 1, that's fine. These guys are going to cancel out, leaving me with an r. 6 times 5 is 30. And there you go. Okay, so if there's a fraction being multiplied, use reciprocals. This time, I don't necessarily have a fraction being multiplied to it, but what I do have is I have a 2 on the bottom, so it's saying that it's y divided by 2. So to get rid of a division, we use the opposite, so that tells me to multiply by 2 on both sides. So this cancels out and that cancels out. Y equals negative 10. Okay. So pretty straightforward, 3 types of problems. Just a straight up multiply where they're next to each other. This one, looking at the green, okay, it's a multiply, but it's a fraction that's being multiplied, so you're going to use reciprocal. And then there's the ones where it's just plain division, and so you just multiply on both sides to cancel out. Okay. So number 4 is which of the 3 scenarios? Is it just a plain multiply like number 1, a fraction, which we're going to have to use reciprocals, or is it like number 3 where we divide? Number 4 is the reciprocal version, okay? But I have a problem right here on this side because I have a what? I have a mixed number. So I want no mixed numbers because we can't do anything with it. So let's go ahead and change that into an improper fraction. So remember, we take the big number on the outside, which is the 4 in this case, multiply to the bottom, and then add it to the top. 4 times 3 is 12, and then 12 plus 1 is 13, so that number is going to go on the top of the fraction. And then we just preserve the denominator, which is 3. So 4 and 1/3 is the same thing as 13 and 1/3. So my problem really looks like this. 2/3 s equals 13 over 3. Remember, to get rid of this 2/3, I'm going to multiply it by the reciprocal on both sides. So this cancels out. So everything cancels out on the left side. And then on the right side, can I cancel things out? The 3's can cancel out. And remember, when they cancel out, it's not 0, it's a 1. So 13 times 1 is 13. 1 times 2 is 2. So s equals 13 over 2. And just like yesterday, if you ever get lost, you can always just re-plug in the number that you find into the original problem and check your answer. So since my cursor is over here on number 2, let's check number 2. So the original problem was 1/5 times r, but I know r is 30, okay, equals 6. So 30 times 1, remember this is really 30 over 1. So 30 times 1 is 30, 5 times 1 is 5, 30 divided by 5 is 6, so I know I have a good answer. Okay. The last thing that I want to look at with you is absolute values. And so equations with absolute values, we want to basically ask ourselves, once we solve or once we get x by itself, what do we have to plug into that absolute value to make the statement true? So I've given you 2 statements here. Remember that when you put a positive number into an absolute value, you end up with a positive answer. And when you put in a negative number inside an absolute value, you also end up with a positive. So no matter what, remember, you're always going to have a positive answer as when you plug in any kind of positive or negative number into an absolute value. A positive number will give you a positive answer, a negative number inside an absolute value will also give you positive. So it doesn't matter what the number is, okay? So let's look at number 5. Same idea, our goal is to get the x by itself, or the absolute value x by itself. So to get rid of this 2, it's being multiplied to that absolute value, so I'm going to divide by 2. Divide by 2. These guys cancel out. So I end up with the absolute value of x equals 18. So think about this. Let's go back to up here in the green that I started with. So what number would I have to plug in here to get positive 18? So the absolute value of what would be 18? This is a positive here. Okay? Let's look at this first green one. So if a equals positive a, the absolute value of a equals positive a, would you agree that the absolute value of positive 18 would give me 18? Is that situation true? That's true, right? If I plug in a positive 18 into an absolute value, it'll give me a positive 18 as an answer. But there's one more answer. Is this true? I'm sorry to put a parenthesis there. If I plug in a negative 18 into an absolute value, will that also give me a positive 18? That's true too. So the answer for x, if I go back here, the answer for x in this problem has 2. It will give me a positive 18 and a negative 18. So those are the 2 answers that x has to be able to give me, to make this statement true. Okay? Let's look at 6. So remember, to get rid of this 5 on the bottom, I'm going to times everything by 5. Since it's being divided, I'm going to multiply. So we get square absolute value of x equals 10. And so what would I have to plug in here for x? X would have to be a positive 10, but it would also have to be what else? Also a negative 10. Okay. So you're basically just looking at, once you're able to get x by itself and the absolute value, look at what the number is on the right side, and just the answer is basically just a plus or minus version of whatever you get on this right side of the equal sign. Here we go with number 7. So I have a reciprocal problem, right? Because it's a fraction being multiplied to the absolute value x. So reciprocal on both sides. I'm going to multiply 3 over 5 there, and then also 3 over 5 here. If it helps you, go ahead and make that a 10 over 1. But all this stuff here on the left side cancels out. So I have an absolute value of x equals, you can look at it like this, the 10 and the 5 can go into each other, there's 2 left over. 2 times 3 is 6, and then 1 times 1 is 1, so the absolute value of x equals 6. So x has to equal our number here, which is 6, the positive version of it, and the negative version of it. Okay. Again, just take this guy, once you get this absolute value x by itself, take this guy and just put a plus or minus in front of it, and that will take care of it. Here is number 8. Let's practice again. So number 8 is a divide problem, so to get rid of that 8, if it's a divide problem, I multiply to get rid of it. So 8 on both sides cancels out. 4 times 8 is 32. So to figure out what just plain a is and not absolute value a, we write that answer, 32, and then throw a plus or minus in front of it. And there we go. Last problem, 4 over 7. It's a reciprocal problem again, because it's a fraction times an absolute value. 7 over 4. Cancel, 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 cancel. I'm left with this. Okay. And so what do I have here? I have times 7 over 4 on the left side. If it helps, put that 16 over 1. And then we cancel those two guys out. Okay. 4 times 7 is 28. And then you have your two ones there. 1 times 1 is 1, but they're not necessary. And so remember, x equals, take our answer, and then throw a plus version of it and a minus. And there is absolute values.